All right, in lesson 6.3.2, we're going to talk about factoring perfect square trinomials. Back in the factoring flowchart, yes, GCF is still first, but under trinomials, we've spent several lessons talking about trial and error with and without GCFs, with and without leading coefficients other than 1. But now we're going to talk about this other branch, which is perfect square trinomials. So in order to do that, you need to review squares. Now, sometimes called perfect squares. If I said, what's the square of 1? 1 squared is 1. 2 squared is 2. No, it's not. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. And I'm tired of squaring numbers. You can use your calculator, of course, to square numbers or to take square roots. All right, so those are perfect square numbers, but we need to actually review perfect square trinomials. They are a result of squaring not numbers, but squaring binomials. Suppose I had 3x plus 5, quantity squared. You could do it two ways. One way is to simply say 3x plus 5 times 3x plus 5 and use FOIL. The product of the first, 3x times 3x, is 9x squared. The outer product is 15x. The inner product is another 15x, and that always happens when you're multiplying a binomial times itself. So you get double that value, or 30x. Then for the last, 5 times 5 is positive 25. You might remember a squaring process that was a shortcut from a previous course. In this case, when you square a binomial, you square the first. 3x times 3x is 9x squared. To get the middle term, you multiply those two. That gives you 15x. But you have to remember that that is both the outer and the inner. Outer and inner. So you have to double it or multiply it by 2 for 30x. Then you square the last one for plus 25. This will be a perfect square. This will be a perfect square. The middle will be double the product of their square roots. So if you recognize something is a perfect square trinomial, it's easy to factor. If you don't recognize it, you're not going to be lost. You'll just do it by trial and error. So let's take a look at some perfect square trinomials. It's going to try to make that a little bit bigger. Well, let me see if I can do this another way. There we go. That worked. All right, factor the perfect square trinomial. Now, you were kind of given a gift here because in the problem's instructions, it told you it was a perfect square trinomial. So x squared plus 14x plus 49, because they're saying it's a perfect square trinomial, you know that it will factor into a binomial squared. To get what goes in there, take the square root of that. What do you have to square to get x squared? X. You're always going to take the sign from the middle. What do you have to square to get 49? 7. You just factored that polynomial. Check it. To get this term, x times x is x squared. Multiply them for 7x, double it for 14x. 7 times 7 is 49. If you did not know it was a perfect square trinomial, you could have done trial and error and said, oh, they're both plus. I know I need x and x. I need factors of 49. Is it 1 and 49, or is it 7 and 7? They have to add up to be 14, so it's 7 and 7. These are both answers, either one. Next, factor the perfect square trinomial. Okay, x squared minus 18x plus 81. Because it said it was a perfect square trinomial, I know it is something squared. Square root of x squared is x. Sign from the middle. The square root of 81 is 9. And I've done. You could check it. X squared is x squared. 9 squared is 81. Multiply them for negative 9x. Double it for negative 18x. Next one. And I am sorry, I don't think I've been saying it. I've been thinking it, but you're still supposed to be saying, is there a greatest common factor? And there's not. So, perfect square trinomial. When you see that perfect square, then please take advantage of that, and you know that it is that. Remember, when the last sign is positive, both signs have to match the middle, so they both have to be negative. The square root of 9x squared is 3x. The square root of 64 is 8. Let's see if we have it. Check the middle. Multiply those for negative 24x. Double it, negative 48x. We've got it. Remember, if you did it by trial and error, you would get 3x minus 8 times 3x minus 8, and that would be correct also. Factor the polynomial if it is a perfect square trinomial, or state that it is prime. Okay, well, let's see if we have a prime one. All right, it's perfect square they're making it sound like it is a perfect square trinomial or not, or it can't be done. So here we go. The last sign is positive. That means both signs are plus. What do you have to square to get x squared? X. What do you have to square to get 64y squared? You need an 8 and a y. It is very common to see people leave off the variables. Let's check the middle. Multiply them for 8xy in alphabetical order. Double it for 16. Got it. If you know something is a perfect square trinomial, then that really takes some work away. Next one, m to the third plus 26m squared plus 169m. And all it says is factor completely. Okay. Is there a common factor? The answer this time is yes. M is a common factor. If I divide each of these by m, that's going to make it m squared plus 26m plus 169. Now, something that I notice, m squared, of course, is a perfect square. The 169, it is very helpful if you happen to remember numbers in this list. 169, yes, that's a perfect square. That means that this is what I would call a candidate for being a perfect square trinomial. Keep this GCF of m. I'm going to try. If I'm wrong, I'll erase. But I'm going to see if it is m times something squared. The last sign is positive. That means both signs. And when I say both, this is a squared, so this represents both factors. So I'll have an m, because m, that's the square root of m squared. What's the square root of 169? Back to that list at the beginning, you find out it's 13. Let's see if this makes 26. Multiply them for 13m, double it for 26. You need to have all of this as your answer. Now, if perfect square trinomials give you trouble, remember that you can always use trial and error, and it will work as well. Okay, try to recognize your perfect square trinomials.